continuing with our triangle, congruent triangle. So we've already done side, 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 talked about side, angle, side, we've talked about hypotenuse, leg. Now in our triangle congruence lab, we saw some other pieces. Angle, side, angle. Angle, side, angle. It's also a postulate. So what does that mean? If two angles and the included side, that is the important part of this, the side is in between the two angles. If you have that situation, then you have congruent triangles. Included means between the angles. Has to be there. So you read these in the order. Angle, side, angle. So here's an example. I'm going to see if this is on here. I don't think it is. So we'll just look at it. Can we prove triangle PQR congruent to RSP? Now, based on the drawing, this angle is congruent to that angle. This angle is congruent to the other angle. And what do I know about PR and RP? Well, they are the same segment, therefore it's congruent to itself by the reflexive theorem. So I've got an angle, side, angle congruence in both triangles. So yes, we can, using the angle, side, angle congruence postulate. So just like what we did the other day, it's just now we're looking at a different pattern here. The other one we have is the angle, angle, side. Calling this side angle, angle is perfectly okay as well. You could call it either one. If two angles, and this time it's not an included side of one triangle congruent to two angles and the corresponding non-included side, then they're congruent. So again, read it. Angle, angle, side. Angle, angle, side, instead of angle, side, angle, we put it here. So do you see that difference? That's kind of really key here. That it's not an included side. Not. Yeah? Give me just a thumbs up. Yes! Yes, away! I get you. I just want to make sure you know the difference between angle, side, angle, and angle, angle, side. All right. So let's do a proof of this. Let's see. So what do I want to prove here? Got to mark my diagram. Angle A and angle B, and I know they marked it, but I marked it too. Angle C to angle F, and BC congruent to F. Boy, it didn't look like. So let's see here. AD congruent to BCF. That's my gibbons, right? Why is angle B congruent to angle B? Oh, that's a good one. Why is angle B, Yeah. Well, we had something to guess. We had something called the third angle congruence theorem. What was that one? That one said if you have two corresponding congruent angles, then it must be that the third is congruent. No way. Okay. That is the third angle congruence theorem. Just bringing that up there. So triangle ABC to triangle DEF. I've got all kinds of reasons here. I already had the angle, angle, side based on what they gave me, so we just did the other one for last year. But I can say angle, angle, side. I also have an angle, side, angle. I could have used that one as well. So sometimes there's more than one way. All right, so this one, an angle, angle, side example. Can we prove these two things congruent? This one, this triangle RST to B to T. Automatic. It needs to become automatic. Whether we need it or not, I don't know. As soon as you see a vertical angle, mark them. You never know. But, well, that helps us. Angle, angle, side. Right? Read that in order. This is not an angle, side, angle because it's not an included side. All right. These, I believe, I hope, are on your thing. Yes. Okay, we're just going to go through them. And can you kind of just look at what we got here and determine whether you've got congruent triangles or not, and why or why not? So immediately, you have to get in this habit. Oh, look, vertical angles, let's mark them. All right, anything else I know? Nothing I can figure out. Do I have enough information for congruent triangles? Julie says yes. How come? Angle, side, angle. Angle, side, angle. Yeah, that's it. Oh, can we do angle, angle, angle?
No, not for this one.
You tell me. Now, what did we do? We did this with the, our little experiment, and we said if we have an equilateral triangle, right, what are the measures of the angles? They're all 60, right? Does it matter what the side measure is? Like if this is 10 centimeters and 10 centimeters, right? What about a triangle that's equilateral, they're all 5s? Are these congruent triangles, Joseph? Are they? No. But what's the measure of these angles? So I found a counterexample for angle, angle, angle that it's not going to work. Sometimes it does, sometimes it doesn't. So we don't have that as a congruence theorem. What was the other one that didn't work? The one that's a little bit, I don't want to say naughty. Makes me think of a donkey, that one. Huh? Side angle, you remember it. I think you laughed the loudest last time, I'm pretty sure. Side angle doesn't work. Side angle and angle, angle, angle. So we'll remember those. Doesn't work. Just to remind ourselves. Right? Angle, angle, angle. I want you to keep in mind this counterexample to it. And side angle. We're just going to remember that one, right? You read it backwards to get something about it. Okay. So congruent triangles here. What do I got? This is the next example. Joseph, what do you think? First of all, I have to mark my verticals because it should be an automatic. I see vertical angles, I'm marking them. Do I see anything about sides here that I can figure out? I don't see it. They didn't tell me anything about bias or nothing. So all I've got are angle, angle, angle. So tell me, Joseph, are they congruent? Or can I conclude they are congruent? I cannot conclude they are congruent because angle, angle, angle is insufficient to prove triangle congruence. And that's all I've got, angle, 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 and it's insufficient to prove triangle congruence. That's what I got. Okay? Let's see, what's the next one? Alright, what have I got here? Okay, well, what do you think? I don't think I can mark anything else that I can notice. Are these congruent triangles or not congruent triangles? How come? Angle, angle, side. Angle, angle, side. One's the flip of the other, that's okay. I still have angle, angle, side. Please stop me if you have a question. You're like, what? Please stop me if you have a question. Alright, now, next one here. This is letter D. Vertical angles, gotta mark them. It's automatic. I may or may not need them, but it should become automatic when you see a diagram. What do you think? What do you think, Amanda?
I think that it is congruent. Because of the angle, side, angle, congruent.
Angle, side, angle. Good. You know what she did not do? She didn't say, oh, it must be hypotenuse length because it's a right triangle. It's not automatically hypotenuse length just because it's a right triangle. It might be. But not in this case. I don't know anything about the hypotenuse in this triangle. Good. Alrighty, let's see what we got here. Oh goodness, alright, I don't see anything else I can mark. Are these congruent triangles? And I'm looking at letter E here. Congruent, not congruent. What do you think, Joseph? Why? What? Angle, angle, side. Guys are so loud otherwise when it's answer to a question. Very quiet. Just too busy. Alright, what about this guy? I don't think I can mark anything else about it. Is this thing, these two things congruent? Why do you say that, Amy? Yeah, we've got a side angle. That's a no, because side angle is insufficient. Oh, that's not spelled right. Insufficient. Let's try it again. Insufficient to prove triangle congruence. Right? So what are the two that don't work? Yeah, Joseph? Let's see, it's nice and loud. Yeah? Side, side angle, and angle, angle, angle. It's like international interdiction symbol, there we go. Maybe they don't work, yes. Oh, so if you're gonna say this one backwards, this is what you're gonna get back at you? I like that. That's right. So why would he get mad at you talking about it? I don't know. Okay.
If the teacher says that, everyone's probably laughing.
Well, maybe. Okay, let's do a proof, because you guys have to get over the fear of proof. I think I'm gonna call it proofophobia or something. Gotta get over it. We can do this. Do it.
No, it has to be like something clever, like
That is clever.
No, it's not.
What's
You
the
need to rename proof in the most complicated way possible.
Well, you work on that for me. I'm going on with this proof here. First thing, mark the diagram.
We should proof of man explaining himself and then
Okay, you guys ready? So angle PQS, let's find it. PQS, that's this one. Congruent to RQS. Okay, that's that one. I know they marked it. I just have to see it. QSP, this guy, to QSR. Those are congruent pieces. Now what else can I mark here? Not this guy. So now what? Oh, wait a second. Do I have congruent triangles? Are PQS and RQS? Why? Angle, side, angle. All right, they do that first. Then the proof is just, let me just do it. So you write down your givens. That's always a good place to start if you're not sure where to start. So I'm going to do them in one statement. I think it just makes it a little simpler. That's my given. And then what did we do? We said, oh look, we've got QS congruent to QS because they share that side, these two triangles. And that is the... So what are you hanging here? What's the reason? What's the reason? Everybody should know it. Raise your hand if you know it. Yeah, raise your hand if you know it. Because I'm calling on you if you don't. What? Oh, every hand just went up. Hi, my friend. Why is that? Why is QS congruent to QS? You did know it. Okay. And now right away, I'm there. Triangle PQS is congruent to triangle RQS by what? Angle, side, angle, congruent to posture. That's it. Yeah. I think there is, and he's working on a complicated name of that for me. Yes. You know what? I'm kind of okay with that. I'm okay with that. Yay! Because it's shorthand for the angle, side, angle, congruent to posture. That's good. Right, now is this hard? It's hard on me, you make it hard. Yes? You write that down. You write that word down.
Just say it's not enough.
All right, let's try this guy. KLN congruent to MLN. I gotta mark my diagram, so let's see. KLN, oh, look, they did it for me. I'm doing it anyway. MNL, that's here. And I also know that KN and ML are parallel. What do I want to prove? That these two triangles here are congruent. Well, right away, I'm going to mark my, my reflexive side. I see that. Is that enough? Gives me an angle, and it gives me a side. Not enough. I tell you what, you see parallel. I'm going to look for Z's. Oh, there it is. Which means tucked in the corner of the Z's are my alternate interior angles, and alternate interior angles are parallel lines are congruent. Is that enough? What do I got here? Jacob, what's the reason that these are not congruent? Angle, side, angle. So now it's just a formality. Okay, let's write them down. Okay. KLN. I'm writing down my givens. And then what did we do in the analysis part? We said, oh look, now does it matter which order you gave it in? Maybe you want to do your alternate interiors, but it doesn't matter. I'm going to go with my, I'm just going to go with the alternate interiors. Why not? So angle KNL congruent to angle MLN. Did I say that right? Alternate interior angle of parallel lines are congruent. I think I said them right. And then I'm going to use my reflexive property. So LN is congruent to NL. And I'm saying them kind of backwards just because my triangles are turned around a little bit. Reflexive. what would we ever need this for? Maybe a little thing. And now I have enough to say that the triangles are indeed congruent by, as David said, this side. So marking the diagram first should make this easy. If you don't mark the diagram, hard. Yes, sir.
Oh, no, yeah.
What? You know if it was a theorem or what it was? If you said reflexive property of congruence, I'm not marking it wrong. That's okay. All right, I got a U try for you to actually try it. Click here. See if you can do it. Here, I'm back here. So let's see. I'll show you what I got. Now, how do we do? Did we mark the diagram and say, okay, here's angle S, here's angle B, here's RS, here's that. Automatically, I'm going to mark my verticals. Let's see if that helps me. Well, what do I got going here? I've got an angle to angle side. So all I had to do really was write down my given, mention that I noticed I've got these congruent vertical angles here, and then write down that we've got an angle side. Or if you wrote side angle, that's okay too. Yeah. Angle T. Which angle T? The problem is I've got an angle T here, an angle T here, an angle T here, and an angle T here. Now if you're saying it's this version of angle T and this version of angle T that are congruent, they are not the same angle, are they? Therefore, it's not the reflexive property. It's only the reflexive property if you were talking about angle T, this one twice. You wanted to say RTS congruent to RTS. That's reflexive. But we've got actually 4 different angle T's here, so you have to be very specific which one you mean. So that's why I wrote out the RTS to UTV. So be careful. I could say angle R, and I could say angle S. That is unambiguous. But when you have more than one angle involved at the T vertex, you have to give the full 3-letter name. Yes, ma'am. Amanda.
Why is angle side if you're the angle side angle is just partial?
That's probably provable.
How did it prove?
I am not taking the time in class to do that one. I can find you that information if you want to. But right now I want to move on a little bit. All right, how do we do? Did you write your own? How many people were able to write their own proof from scratch? Okay, good. You're getting better.
I wrote it from the paper.
All righty. Using congruent triangles. Now, one of the reasons we go through this is, it is a good mental exercise. It is a good exercise in logic, deductive reasoning, critical thinking. But from a practical standpoint, sometimes you actually, using congruent triangles helps you find other things that are congruent, in practical terms. So remember CPCTC, how could you forget it? Remember that guy? Yeah, what does that stand for? Corresponding parts of congruent triangles are congruent. So we're not watching that thing, I'll tell you that. What we do with CPCTC is, so let's say you have 2 triangles, and you knew, let's say you had a side angle inside kind of thing. Okay, can I continue? Alright, so let's say you proved 2 triangles were congruent using side angle side. I proved it. So what do we know about congruent triangles by the definition of congruent triangles? Remember the definition was all the corresponding sides are congruent and all the corresponding angles. So once I have established that I have congruent triangles, I know that this side's congruent, this angle may be congruent to that one, and this angle is congruent to that one. So what we're going to do here is by saying, let's say I have proven that I have my congruent triangles, but now I want you to prove that these 2 things are congruent. So if you're given 2 triangles and say, prove those 2 sides are congruent, go ahead and prove the whole triangle is congruent, and then say, well then these must be congruent as well, because corresponding parts of congruent triangles are congruent. Alright, let's look at an example here. It's on your paper here, it's not left on page 2. Explain how you can use this information. So suppose you're given this situation, here's my figure. AB is parallel to DE. I marked that diagram, gotta mark it. And I also know that AB is congruent to DE. And what I want to prove is that C, right here, is the midpoint of BE. Let me just kind of highlight BE for you. Here's BE. And I want gotta show that this piece congruent to that piece, right? Because that's what a midpoint is. So the way I would go about doing that is say, hey, wait a second. I think I can show that these two triangles are congruent because, first of all, I always mark my vertical angles because it's a habit now. I just a reflex. So I'm almost have congruence here. I've got a side and I've got this angle. These are parallel lines and I see a Z. So that means that this one's congruent to that one. It also means the other side as well. I don't really need it because now can I tell that these are congruent triangles? I've got an angle in the side, angle in the side. These triangles are congruent. And once they're congruent, that means that all the corresponding pieces are also congruent. So that means that BC must be congruent to that one because corresponding parts of congruent triangles are congruent. Therefore, C is the midpoint. Yeah, okay? So basically what we did is said, let's show that triangle ABC is congruent to triangle DEC. That can prove them congruent using, what do we use here, angle angle side? And then I was able to show that BC is congruent to EC, which means C is the midpoint, because corresponding parts of congruent triangles are congruent. So once they're congruent, all the pieces are congruent, and I can use that if I need to. Let's look at another example here. So explain how I'm going to use this information. All right, so I've got JK, I'm given. JK is congruent. Oh, wrong. Oh, that's incorrect. That should say JM, shouldn't it? Let's make that correction. That should say JM is congruent to LM. So let's make that correction. On D on the upper right, I believe I actually did make this correction. It's on the Trello card, the calendar for tonight, if you want a good copy of this. So this one is congruent to that one. Angle KMJ. KMJ is congruent to KML. And I can't help it right away. I see a side, maybe I need it, maybe I don't, but I see that reflexive side. Can I see that these two triangles now are congruent? Triangle JKM is congruent to triangle LKM. Why? Okay, what do I got going here? And how come?
Well, we can be proven congruent by the fact that, that the reflection property says that the light CPCTC is congruent to itself.
Mm-hmm.
So that means you have two congruent segments.
Well, I need to get me my congruent triangles first. How can I prove that these, what theorem or postulate should I use to say they're congruent?
Okay.
Yeah.
So, SAS.
Yeah, triangle side. So can I reach the conclusion, which is, can you show me that JK and LK are congruent? Yes, I can. Because since I have congruent triangles, then all the pieces are congruent. So now I can conclude, yeah, those have to be congruent because of corresponding parts of congruent triangles being congruent. CPCTC. So I can get those pieces now. This one's a little tougher. Hey, okay. So let's see, what do I have here? This one we need our thinking caps. Angle 1 is congruent to angle 2. And angle 3 is congruent to angle 4. Now what am I trying to prove here? I am trying to prove that DEF, this guy, is congruent to DCB, that guy. Okay, this one's a little tough. Now wait a second. My vertical angles, I'm automatically gonna put them there. But now I just got an angle. And can I figure out anything else? I don't think so. So I kind of went about this a different way here. I said, well, first of all, I do know that these two things, that's EDF and CDE, those are my vertical angles there. That's just what I did on that step. But let's see. I need to show here something else. If I can show that ED and CD are congruent, I mean, there's other possibilities here, but if I can show these two, then I'll have an angle-side angle. So I'm thinking ahead because I think I can do these two triangles. So let me kind of mark those. I'm gonna look at these big triangles. This is a complicated one, by the way. Can I show those triangles congruent? Let's see, heard of that already. ADE, that's this big triangle. Is that congruent to ABC? She's saying yes already. How come?
Because, they have the same angles.
Uh-huh. Got angle, angle.
You have a vertical, and then the angle FDE is, the same as angle CDE, so that means that the left over ABF.
She's saying this piece matching?
Yeah.
But it gives me angle, 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 but I need a side, right? But look what I got here. I've got, they share a side. So you're right, all the angles work, and I've got a side here. So what can I use here, to show that those green triangles are congruent? I use angle, angle, side. I said you got an angle, you got an angle, you got a side. You got an angle, you got an angle, oops, and a side. So the green triangles are congruent, which means that DC and DE are congruent by CPCTC. DE to DC, look how complicated this one is. By CPCTC. So now I can go back to my red triangles. Look, I got angle, side, angle now. Oh, so yeah, this one was a kind of a complex one. It just shows you can really kind of dig into these if one wanted to. Why would you not? Because it's fun. Somebody have fun with this? I
Yeah,
am.
I did.
Good. I think where it's you and me. It's good for me and Amanda are having a good time. I don't know about everybody else. Everybody find this a little bit fun, a little interesting? A little neat? Come on. Okay. All right. Just you and me, Amanda. All right, let's try this next one. You got this written down here? We have a question? Yes, sir. Huh? What can we conclude about EB and DC? They are congruent by CPCTC. Right? Yeah, it was a hard one, but that's good. All right, let's look at this guy now. So let's see what I got here. AB is congruent to EB, and FB is congruent to CB. Fantastic. I want to prove, I'm going to just make that a different color. I want to prove that BG and BD are congruent segments. So, oh goodness gracious. So, what triangles can I easily prove congruent here? I see a side, right? I see vertical angles. So what triangles can I easily prove congruent? What do you think, Julia? Let's see. Which one? GBF. How am I easily doing that? Oh, you're doing these two? But not to each other. Right, reflexive angles are the exact same thing. So that would give me like these two. I'm looking at a big picture here. Look at a big picture. How about those two triangles? We have a side angle side here. I picked triangles to I got it already filled out, so you don't have to use my writing there. Why did I pick ABF and EBC, the big triangles? Mostly because I could see it easily by this side angle side that I had going here. Okay? Now, I'm still trying to get BG and BD. That doesn't help directly, but what else does having those two big triangles tell me?
It is enough.
What it is?
Yes.
How do I know that these are congruent?
Because of SAS, therefore they're congruent, therefore they have the same height.
Wait. What's congruent? Therefore, what's congruent?
ABF and EBC are congruent.
Okay.
Therefore they had the same height, and GB and BD are.
You're saying
height
this,
of the
so height, what do
triangle.
you mean by height?
Like base times height, the height from the base.
How do I know this is the height? Height has to be a perpendicular. Right?
Because it's from the base to.
I don't know that this is the height. How do I know this one isn't this way and this one isn't way perfect the other way? I don't know that. So, here's what I'm gonna use. I'm gonna use CPCTC to say, well, you know what, if these big triangles are congruent, you know what else is congruent? Their angles. So, all those angles by CPCTC have to be congruent. So, now, I'm gonna look at some other triangles. You can find other ones in this. I'm picking these two. I'm picking those triangles. There are other triangles that will work here. I hope that's what I can do. GDF and DBC. I picked those because now I can find them congruent. How come? Because I've got a congruent angle here and I've got congruent sides. And you know what? I see another X. These little ones here are another X. There's vertical angles within there. So I've got angle, side, angle. Yeah, so I've got like an angle, side, angle for these guys. So these are congruent triangles, which means what? That this side is now congruent to this side by CPCTC. Anybody's head just going that, you know? Or if that happened a while ago. What? I will say these last two are definitely more advanced uses of CPCTC. And I wanted you to see some of the more complex ones. So if you go back to the easier ones, they're not so bad. But you really, this is thinking. This is what we call critical thinking. It's all the rage. Yeah. It's a good thing. So, questions before I turn you onto the U-try. No. Are there questions? Why don't you try the U-tries? You may have, yes?
What's the difference between planning a proof and writing a proof?
Just thinking about it, now you would have to just one, two, right? You have to write this all out formally. So what I would say for these U-tries are just, these are all planted. Write the proof. Plan approved. Write it. Write a proof. For those two things. I think that's easier than, you're right, planning is hard. So give it a shot. I kind of wrote it like this. I did actually plan it. Basically, I said, let's see, PR congruent to RT. So that would be like your given, right? And then you would say angle Q congruent to angle S. That's another given. And they are parallel. PQ and ST are parallel. Given, right? So I wrote it in a paragraph too. Given these things, now we can conclude that angle PRQ is congruent to angle RTS because corresponding angles of parallel lines are congruent. Therefore, triangle PRQ is congruent to RTS by what? Side angle, angle, side, sorry. Angle, side, angle, side. And so, once I know that I have congruent triangles, I can say that RPQ and TRS are congruent angles by corresponding parts of congruent triangles are congruent. Okay. Yeah?
But it's possible to prove it with, I prefer it a different way.
Yeah?
Where, since these two lines are parallel, and angle Q is equal to angle S, that means the transversals have the same angle. So if you were to make a parallel line through point P parallel to the other two lines,
I lost you. Okay, say it again.
So angle Q equals angle S.
They are congruent, yes.
And since RQ and ST are parallel, if you were to create, using construction, a parallel line parallel to those two, crossing through point P.
Create parallel lines here?
Yeah, and then angle QPR and SRQ would be zero because of corresponding parts.
Huh?
You,
How does having this parallel line help me?
well, you don't need the parallel line, but since the two angles are the same.
Which two angles?
Since angle Q and angle S are the same, you know that SR and PQ, if you were to draw a parallel line, you know it must apply because it's the same height.
What am I drawing parallel? I'm completely lost here.
Okay.
Completely.
So,
What am I drawing? So this is not what you want up here?
because.
These two things are congruent.
Yes.
So, yes.
So, actually also, the fact that RT and PR are congruent, so that means that.
Wait, what is?
RT and PR.
They are congruent, you know that?
It says so.
Okay.
Therefore, we know that point P is the same height above the triangle as point R.
Why?
Because they have the same.
Because it's the same
Oh,
angle
because they're
and the
congruent.
same
PR
side.
is the same height, so you're just saying they're congruent.
Well, it's the same height above the triangle at the same angle, so therefore it must be equal.
What theorem are you quoting here?
Father.
I need a theorem. I don't even know what you're saying.
Say
I don't even know. I need a theorem. I need some, like, not like, because it kind of is. What?
Looks like
All right.
saying that a miracle happens.
A little bit. You probably have something there, Jack. I'm not trying to discourage you. But I want you to kind of give me, like, some real theorems there that we can really describe and explain. Other than, because it must be, see? So I need more than that. So see if you can come up with some theorems. We can do it. All right, so this diagram says this one congruent to this one. We got an angle here and an angle here, and I want to show that this is congruent to that. Now, hopefully, we did this automatically. See an angle side, and we made those congruent angles that way, and then we can conclude by CPCTC. Now, let's see, I wrote this one, I did write as a proof. Wait, so I wrote that these things are exactly what the little diagram said, so given. Then I mentioned that I've got the vertical angles. Then I saw I had angle side congruent. Therefore, DB and CB had to be congruent by CPCTC. Now they could have mentioned, they could have said, show B is the midpoint of DC. They could have said something like that. Now you do the exact same thing, and I would just have another statement that said B is the midpoint. Now it isn't here, so you wouldn't do that, but you can. So you can take these a little bit further if you need to. If they had said, show that B is the midpoint. So, yeah, you guys did a lot here. If you didn't finish your checkpoint, do you think you have a little bit better strength now with the proofs? Maybe go back and try it, see if you can finish that before then. Otherwise, that is our discussion.